Hello. Finally. This is Prof. Nanius, and we're going to do a little bit of algebra review. And this one is going to be for inequalities involving absolute values. So if I can get this to work, finally. Here we go. And get this off. All right. That didn't seem to work here. I don't know why it's acting so funny, but it is. There we go. So, inequalities involving absolute value. Now, the absolute value function here, if you have the absolute value of x, this is defined to be conditional in a conditional way. It's going to equal x for x greater than or equal to 0, and its opposite for x less than 0. For example, if you had the absolute value of minus 3, well, we see that minus 3 is in fact less than 0, so we're going to be using this formula here. So it's going to be the opposite of negative 3, which is positive 3. So the question is, using this, how do you solve an inequality that looks something like this? 5x minus 7 is greater than, let's say, 8. So how do we solve that inequality algebraically? Well, what we know is that 5x minus 7 is equal to itself. So this is going to equal 5x minus 7 for 5x minus 7 greater than 0. Or it's going to equal this for 5x greater than positive 7, which you get by adding 7 to both sides, or for x greater than, because 5 is positive, when you divide both sides, you keep the inequality the same way. So that's what that is. Okay. For x greater than 7/5, 5x minus 7 is in fact greater, for x greater than 7/5, that's what we have. So going to our inequality here, for positive, this means 5x minus 7, if this is positive, is greater than 8, which is 5x is greater than 8 plus 7, which is 15. Well, 5x is greater than 15, and since when you divide by 5, you do not change the inequality, we get 5. Oh, gosh, divide both sides by 5. So that occurs when x is greater than 3. And we can check that out here on that, well, right, for that. Or this can be the opposite of 5x minus 7 is greater than 8. Or it could be its opposite. Now we do have to worry a little bit, because if we multiply both sides by -1, we change the inequality. So the inequality goes to this. And then when we add 7 to both sides, we get 5x is less than minus 8 plus 7, or 5x is less than -1. But 5 is positive, so we can divide by that and keep the inequality the same. So we get this. So our answer means x is greater than 3 or x is less than negative a fifth. And now let's plug in x equal negative a fifth to see what happens. 5 times negative a fifth is negative 1. Negative 1 minus 7 is minus 8. And since we're taking the absolute value, as we are here, in fact, let's just go ahead and check this formally. So let's just check. It's important. Let's say we have 5x. And I should have 5x minus 7 is greater than 8. So let's say check if x is 3, we get 15 minus 7, which is absolute value of 8, and that's equal to 8. So you make it bigger, well, that works. We check x is negative 1/5. We get 5 times negative a fifth minus 7 is negative 1 minus 7, absolute value of negative 8. And in fact, that's equal to 8. So that checks too. So we did it right. Now let's do one more. It's a little bit trickier. Let's say we want to do this one here. Let's say we'd like to do the negative 2x plus 5. Let's say it's greater than 7. Okay? Well, the first thing is minus 2x plus 5 be in fact greater than 7. Minus 2x is greater than, subtract 5 from both sides. So minus 2x is greater than 2. But then when we divide by negative 2, we have to reverse the inequality. So we get this right here. X is negative 1. In fact, that works. Or we have the negative of minus 2x plus 5 is greater than 7. That is minus 2x plus 5. Multiply both sides by negative 1, and you have to reverse the inequality. Minus 2x, subtract 5 from both sides. That's negative 12. Or we get minus 2x is less than negative 12. And then we divide both sides by negative 2. We have to reverse the inequality, and we get x is greater than 6. Now, if we plug this in, 6 times minus 2 is minus 12. Minus 12 plus 5 is negative 7, and you get the equality. So your answer here is x is greater than 6, or x is greater than negative 1. All right? Now let's do one more, and then we'll call it a video. Let's say we have the absolute value of 3x plus 5 is less than 4. Okay? Well, what this means is that 3x plus 5 is less than 4, or its opposite, these two together. But then if you multiply through by negative 1, well, so I have to be careful here. Yeah, that's correct. If you multiply through by negative 1, I get 3x plus 5 is greater than negative 4. So we have this condition, and then we have this condition that this, either one works. But notice 4 greater than this greater than this. So when you have the inequality like this, where you have something less than a positive number, we get 3x plus 5 less than 4, as we have here, or greater than negative 4. And we can write this as one inequality because these can happen at the same time. Now, what we can do is we could subtract 5 from both sides. Subtracting 5, we have 4 minus 5, and here we have minus 4 minus 5. So minus 9, 3x minus 1, and then divide by 3. And you keep the inequalities the same way. And there's your inequality. So that's a little bit about a quick review of inequalities and with involving absolute values. Thanks for watching. And this is